Bonjour. Hi, my name is Serge Dandache. I'm the General Manager of Spectra Research Corporation, one of the subsidiaries of the Allan Crawford Associates group of companies. We are a distributor of scientific equipment from multiple world-leading manufacturers. Their field of applications are surface science, materials characterization, spectroscopy, imaging, microscopy, and manufacturing. And today I'd like to talk to you about one of our suppliers from South Korea, Rokit Healthcare. They're really been a pioneer in 3D printing, 3D bioprinting more precisely. And I'd like to take you over to a room where we have one of those innovative technologies. All right, so now we're sitting, or standing rather, beside the 46 bioprinter from Rokit Healthcare. And before I describe this nice piece of machinery, I'd like to justify my claim that Rokit Healthcare is a pioneer in 3D bioprinting. They were the first to introduce a clean chamber technology in an extrusion-based 3D printer. We're talking about high-performance fans that direct the airflow. We have UVC Germicidal illumination to kill bacteria, and we have HEPA filtration, a bit like a biological hood for those who have used those. So they were the first to introduce that. Another thing that I consider to be a great testimonial about the robustness and reliability of those technologies from Rokit Healthcare is the fact that they've been used successfully in clinical trials and in a surgery room, especially for diabetic foot ulcer. So they have not stopped at that level of innovation, and I'll start describing a bit more the 46 bioprinter from Rokit Healthcare. So this technology has added the following innovation. You know, cell survival, when you're doing cell culture, you want your cells to be incubated in an environment where you control the humidity, the temperature, and the percentage CO2 in the atmosphere. The integration of a cell incubator is what Rokit Healthcare has generated in this 46 bioprinter. So we have the clean chamber technology with the fans that you cannot see here, the HEPA filtration, and the UVC Germicidal illumination. And now you have an incubator that controls the percentage of CO2, the humidity, and the temperature. So now I think it's time for the machine to speak for itself.
Hi, I'm DJ. I'm the electromechanical designer here at SRC, and today I'm talking to you about the 46, an extremely flexible 3D printer we have. This system has three very flexible technologies integrated already within one package. On the left-hand side of it, you can have one of two fundamental technologies. On one option is a filament 3D printer, which we have in this model, or a hot melt extrusion 3D printer. The filament 3D printer allows you to 3D print using a gear system, multiple different filaments such as PLA or other polymers to 3D print on this base using a very specific set temperature that you can do within the software environment. In the hot melt, you use a pneumatic nozzle that links to the top of it at a set pressure and temperature and allows you to 3D print whatever material you want. It also allows you to use bone-like materials to generate things like teeth or bones within the 3D printing environment. On the right-hand side, you have a 5 pneumatic syringe rotary barrel that allows you to print 5 different biomaterials, whether they contain cells or not, at a set pressure because it's all pneumatically controlled. At the heart of the system is its own integrated compressor, which allows it to have a pressure system within itself. So each pneumatic will have its own set pressure, both the left-hand side and the right-hand side. For the pneumatic syringes, Each of the 5 syringes can have its own specific set pressure and its own specific set temperature, giving you the highest degree of flexibility for your 3D printing needs.